I'm very happy to have Björn here, who I know only recently after I heard a Galaxy EU presentation from one of Björn's colleagues about a year ago. And I got really excited about this initiative. And we started chatting about collaboration opportunities. And I'm very happy that in the future EGI flagship project, EGI ACE, we have also Björn's team on board from the University of Freiburg. And we have Björn presenting today what the team achieved in the past 10 years. Before I pass the microphone to Björn, let me just say a few words about his background. He is a trained bioinformatician. He obtained PhD in small molecules and reproducible science. He belongs to the Galaxy Committers group and is running for 10 years a Galaxy-based data analytics service for the University of Freiburg. He's responsible for the European Galaxy server with more than 20,000 users. He is dedicated to best practices and standards in tool and workflow development and advocates transparent and reproducible research. He's passionate about training and community building and provides regular workshops, training courses, and other further education with or without the Galaxy on diverse infrastructures. He is co-founder and core member of the Bioconda and Biocontainer initiatives and part of the Conda Forge core team. Björn has various responsibilities in German and European projects. He's principal investigator of the Denby EPI project, responsible for the Denby Cloud at Freiburg, and co-founder and co-chair of the Elixir Galaxy community. He's also technical coordinator of the Elixir DE node and the Elixir Tools platform. In the EOSC Live cluster project, he is the task leader of the Tools and Workflows work package. So I'm very happy to have him. And I would like to ask you to start the presentation. Right, I can see.
Can you see it?
Yes, we can see the slides perfectly.
Okay. Yeah, thanks for this nice introduction. In the end, I'm just a postdoc, so it sounds way more elaborate than it is actually. Okay, but yeah, I would like to take the opportunity to introduce you to an accessible and reproducible workbench and what we have built during the last years, also in a European-wide context, and how we use more or less a distributed compute network to make that actually scale. The Galaxy project is an open source web-based platform that has in its core more or less the mantra of being accessible, reproducible, and transparent. It started all in the bioinformatics community, but is by now used by different other domains, including material science or climate research. So at its core, it's a framework with various abstraction layers. So you can plug in object stores and various compute resources. And Galaxy is the framework that manages all of that without reinventing the wheel. So Galaxy is really a pluggable framework on different levels. And we have heard a lot of talks today about Kubernetes, HD Condor, and so on. And Galaxy can make use of that if you want to. This project is now more than 15 years old, I think. It was actually started in the USA in the Penn State University back then. And in Europe, so I know that the oldest servers are 10 to 12 years old in Europe. And nowadays there's a huge community that is using Galaxy, that is developing Galaxy in Europe, but also in Asia, Australia, and also Africa. A little bit of our motivation. I mean, you have seen similar slides, and you know more or less the problem. We generate more and more data, and one of the problems is how do we manage the data? But I would like to give a little bit another spin here. What I'm also concerned is not only the data, but also someone needs to analyze the data. And at least in bioinformatics, we have this problem that we don't educate enough bioinformaticians per year that actually can help with analyzing the data that the biologists, the pharmacologists, the medical people actually create. So to make this human factor actually scalable, and I'm not talking here about the compute or data management, just the human factor. We really need to make the compute resources really accessible so that people without command line knowledge can actually analyze data and can actually analyze terabytes of data. And we need to educate also biologists, pharmacologists in a way that they can hopefully do 80–90% of a complex analysis. If then are very complicated statistical questions and so on, then we need to have the expert, the bioinformaticians and the computer scientists. But our vision is a little bit that we enable all researchers, not only the geeks and not only the computer scientists, to actually crunch and analyze data. And this is more or less what we do in the Galaxy project. So Galaxy you can think of is a framework. So it gives you various entry points. The most common that is used is the web portal. So there's a website that you can use and yeah, upload your data and process it. So I will demonstrate that briefly in a few minutes. But there's also various APIs that you can use to do your research on a command line if you prefer to. But essentially Galaxy is this framework, and we use Galaxy to reach out to various communities. So of course the medical communities, but also ecology, climate science, plant science, metagenomics, and so on. And all of these communities have a different tool set, they have a different workflows, they have different training needs. And we try to capture that in this framework and with the auxiliary projects which we are collaborating and so on. And very interesting aspect is also that we data is always a crucial part. I think we agree all on that. So we are actually working very closely together with these data providers, with these big European data providers, to actually get these data seemingly in Galaxy so that you crunch your data, but then also get it out into public archives like Zenodo and so on, get a document identifier so that you can publish your research in a fair and reproducible way. This is how the web interface can look like. But as I said, we also offer API access for people that really want to crunch, I don't know, 10,000s of data sets and so on. So you can do both via the web interface or via a Python library or a Go library. Galaxy has data management capabilities. This is more like how do we represent data to our users. I just want to make that slide and make the point. So if you have more questions, please contact me. The Galaxy ecosystem is really huge, and I can just give a few pointers. So please get in contact with the Galaxy community if you have special questions about one of these special aspects here. But essentially, we have a history, or we offer a history. So one of these columns here is what we call a history. And the entire provenance of an analysis is captured here. So every tool, every data set, with every parameter, which Docker version or which container version is used via the analysis is captured in this history. And this is saved for the eternity in a database. So administrators can actually see and look, hey, this Docker container was known to produce wrong results. So you can actually go back and trace back which users have used this malicious or this tool that did something wrong, some wrong statistics and so on. But on the other hand, this also enables these fair and reproducible character of a data analysis. Galaxy supports all these group role model that we know from a traditional Unix system. Of course, quota, but also some LIMS integration. This is a Labor information management system, and various data in and exporters that you can also write very pluggable for your specific data storage. Another important aspect is these tools, and Galaxy is to a very large degree about these tools. So tools you can think of, if you execute a job, this is a particular tool that you execute. And these tools you can plug in like a plug-in framework into your workbench. And this is not rocket science. You need to define inputs, outputs, and parameters, and then Galaxy can consume that. And such a tool can be distributed to all different Galaxy servers out there. So we have kind of an app store-like distribution system for these tools. So an administrator can simply say, I want to have the genomic tools or the climate science tools. And then you install that in your server, in your gateway, and your users can use it. Tools can use Conda dependencies, containers, modules, whatever you like. This is again a plug-in system in Galaxy, and whatever comes next, so whatever is the newest fancy dependency mechanism thing in the future, we will just add support to Galaxy, and a tool then resolves their dependencies on their own, tries to cache it on the server or on the worker nodes. And then, yeah, these tools gets executed on a cluster. We try to design these tools like the Unix philosophy. So do only one thing, but do that very well. So if you think like that, you have all your Unix tools and now you can drag and drop them together into in a graphical user interface, execute it, and then your workflow are scheduled to the cluster. Talking about scheduling, a few words about scheduling. So I try to make this talk a little bit more technic and a little bit more geeky. As I said, as a framework, Galaxy is very pluggable. So we have all kinds of plugins to send jobs to a Torque or to an HD Condor cluster. You can configure a Kubernetes endpoint, and then Galaxy spawns container in a Kubernetes cluster. So there's a lot of flexibility, but you can also, do you see actually that? But you can also configure all jobs and all tools to take special destinations. So we call that a destination. And let's say your particular tool only works in this HD Condor queue with this GPU. This can be configured on a per tool basis by an administrator, but you can even be more fancy. You can say that this particular user or this user group, if a user from this user group is logged in and want to execute this tool in this version, then this tool goes into whatever, into the Spanish cloud and gets computed there. You can link that with an OpenID profile. So this is a very flexible system where you as an administrator can define where your job gets routed and which compute resources you have accessible. You can even mix that then with storage needs and can say that particular tools needs to have particular fast storage or a particular large temp drive and so on. And then this is handed off to HD Condor and HD Condor does then the rest. And you can bind that to different rules that you apply. And keep in mind, this is a multi-user system. So you can really use the power of different groups, roles, and so on in this entire process here. Once we can schedule tools, that's already cool, I think. So many biologists are just happy to run one tool. But the real power comes then if you combine all these different small atomic tools to some larger entities, which we then call workflows. And this is also possible. So you have this graphical editor where you can put these boxes together, and then you can offload that to a cluster and let it compute. And depending on how compute intensive that is, that can then take days. So this is what we call the asynchronous workflow. So probably the more classical workflows. But Galaxy can also support these more synchronous workflows. So more or less the workflow that you do in your R Studio or in your Jupyter lab. So this entire job scheduling system that I described, or this layer on top of the job scheduling systems, you can use that layer to also schedule your Jupyter notebook or your RStudio instance. So in that sense, Jupyter Notebook is just an ordinary Galaxy tool with the only difference that this tool will run more or less forever until an admin configures it to shut down. But with that, in that way, every user can run their own Jupyter and RStudio instances with the same infrastructure that we use for our classical, more synchronous workflows. And even better, you can then combine both worlds. So you can do the data reduction steps. So in genomics, we have a few terabytes of data. We do a lot of cleaning and then processing with it. And in the end, you end up with a few 100 megabytes of data that you then want to analyze in a statistical way. And now just think about, you use these more traditional asynchronous workflow, you load that off to your cluster. And the end result, you then take over to your Jupyter environment. In the same environment, in the same Galaxy instance, you can access these data sets, you can exchange them. And you now take your Jupyter notebook and process your data directly there where it's already stored. Yeah, and with that, we hope that we can combine actually both worlds together and make, again, this entire thing a little bit more accessible to all our researchers. Yeah, as I said, the Galaxy ecosystem is quite large. Just a few features. So sharing is very important in Galaxy. So you can share everything if you like. So data, workflows, analyzers, even visualizations, Jupyter notebooks, as I said. The authentication and authorization can be done again with different plugins, with different techniques. So if you have LDAP or some kind of OpenID provider, you can plug that into Galaxy and then Galaxy can make use of it. So the European Galaxy instance is, for example, using these Elixir AAI for the moment to authenticate users against it. There's an entire sub-project called Biocontainers and Biocondor or Condor, where we create, or where we have created now more than 40,000 containers, and we distribute them via CVMFS around the globe, and more or less every Galaxy instance can make use of that. We have a lot of small tools, small projects that facilitate the deployment of Galaxy, that makes the installation easier, the administration of such a big and complex system. And we also have an own training subgroup that's called the Galaxy Training Network, where we collect now more than 100 interactive trainings. So you can really do your hands-on training with that. And on the right side, you see alone the administration training that we offer. So you can really get kickstarted here and learn about Ansible, about Terraform and all this stuff. And then if you learn that, then deploy your own Galaxy instance if you like. Yeah, as I said, Galaxy is a worldwide project. We know about more than 160 public Galaxy instances. So they are very specialized ones for analyzing the whale, shark, and they are more specific ones, and they are more general ones. So they are these big ones like the US Galaxy server, the Australian one, and the European one, for example. And all of them have more than, I guess together they have whatever 200,000 users alone, these three instances. And what we are trying to do in this usegalaxy.star project is more or less aligning our procedures, but also our workflows, the tool set, the reference data sets, so that a user can seamlessly switch between Galaxy instances and don't have a big problem when one of these Galaxy instances go down. So we want to be sustainable and we want to prepare for the worst case, but still supporting our users. So we try also to align on that level in this regard. In Europe, that's a little bit special. And this is what this distributed compute network is about. So the European Galaxy server has a lot of compute resources. So I'm actually pretty proud of it. And this is mainly due to the German Network of Bioinformatic Infrastructure and the EGI Cloud and the University of Freiburg. But again, if we think about scaling, and if we think about, I think we get now 1,000 or 1,500 users every month. Of course, this compute resources will at some point be not enough. So we need to have a system in place where we can scale out, where we either get more Galaxy instances in Europe, or this is another model here. We can actually now schedule jobs to different cloud or different HPC providers in Europe. And on the right side on the slide, you see the institutes which we are collaborating, and they have provided compute resources. So a few of them, just a few nodes, but others have provided whatever 2,000 cores to this network. And Galaxy can now seamlessly submit these jobs to the UK, to Spain, to Portugal. And the user doesn't really see that. So this is very transparent. And if everything works, the jobs comes just back, is processed, and can be displayed to the user. And this network is extensible as you like. So we also have one partner in Australia. So there is a possibility, for example, to shift at least the small data sets to Australia. And if this is a small data set but has a long runtime, it's actually worthwhile to shift them over to Australia. So essentially we can harvest compute infrastructure all over the world, but have one central gateway for our users, where we can concentrate on user support, where we can concentrate on making the usability better. And the back end is as complex as it can be and as it needs to be. But essentially we can harvest a lot of data and compute infrastructure worldwide. If you're interested in that, the link is at the bottom. And there's also instructions on how you can set up such an endpoint in your compute facility, in your HPC center, so that Galaxy can talk to this endpoint, and then the data staging and so on is done automatically. Such an endpoint can again work with Kubernetes, with HD Condor, with Slurm, whatever you have should work. Yeah, so there's no need that you need to deploy whatever an HD Condor cluster if you don't have one. So as I said, Galaxy can manage that, and this is a plug-in system, and hopefully it works. Or as you see here, this is actually in production if I haven't said that. So we actually use that to process a lot of COVID data during the year, and that was rescuing our ass. Okay, a few words about the European Galaxy server. Just to have a few numbers. So we opened up our server now 2 years ago, and have by now 20,000 users, and they are coming from the entire world. Of course, a very strong user base is in Europe and should be in Europe. But we try also to offer the service to other researchers in the entire world, and we are pretty happy to also support the African community with their research needs. Yeah, I think we schedule more or less 1 million jobs a month if it's a kind of high peak month, we are above 100,000 workflows that have been scheduled so far on this infrastructure. And as I said, the Pulsar network with these 12 partners is an essential part of that. And I'm very thankful for all partners that contributed their compute resources to this idea. What is also kind of special for the European Galaxy server is that we really try to give sub-communities more or less a home. So you can find different scientific domains, for example, like if you do cheminformatics, drug design, or if you do virology, climate science, you have these subdomains. But this is just a different view on the overall European Galaxy server. So it's more or less really just a different view of tools, a different CSS style, and so on. The infrastructure, the Pulsar network, the configuration, the administrative overhead is completely the same because it's the same server. But with this concept of domain-specific flavors, we try to create sub-communities that care about their own tool set, that can make announcements for their news and so on. So this is a lot of community building included here. And so, for example, we can give, for example, Africa an own subdomain, or at some point use galaxy.africa, still running on our hardware, but trying to engage with people from Africa so they can build their own scientific community on our framework, based on our framework. Okay, so I don't know if there are questions. Otherwise, I was asked to give a small live demo, or at least show this web interface a little bit.
There are a couple of questions, and I think it's a perfect time to pick those up now.
Okay.
The first came in from Sean, asking, are you basing any of this? I think he referred to one of the first slides when you talked about the kind of reproducibility, and you showed those historical diagrams things.
That one will do. Yeah, that's a good one.
Oh, Sean, you can ask the question.
Yeah. So the question is, are you basing this on the research object concept so that you could possibly put in publications later?
Yes.
And so do you have hooks into persistent identifiers so you can assign PIDs to data sets?
Yes and no. So the data on a very low level is stored in a Postgres database. But we export, or this is currently in EOSC Live and in other European projects, these data can be exported in research objects or different. I mean, there are different standards that you can use, and then they can be exported. So such a history can be completely exported in a research object or similar archives. So this is perfectly possible, and people are doing it or working on it. So the data is there. I think in the latest release that was deployed last week, you have the initial concept of an export to research object. We don't, so Galaxy as a platform, don't attach document identifiers, but our idea is more or less to push the research object to a public archive, to Zenodo, to something else, and they give us then a research, a document identifier. So I'm not sure if I want to be involved in giving document identifiers out. Does that answer your question?
Yeah. I might argue with you about it at some point, but
that's perfect. But so Galaxy, so the problem is the bottleneck, and this I can tell you from my experience as a Galaxy administrator, the bottleneck is always storage. It's not compute, it's always storage. So my concern currently is more or less to get people, if the analysis is finished, to get the data more or less as quickly as possible off my system, right? So that I can keep my storage healthy, so that the published data is more or less stored in whatever these big players that then are specialized in data archiving. This is currently my idea, but there are several initiatives in Europe where we are involved that will cover this topic in the next years more extensively. And research object or the row crate objects for the workflows is a very prominent player in this field.
Okay, let's move to Mark's question, who asked about how does Galaxy support or align with the GA4GH initiatives?
As good as we can. So Galaxy, for example, gained TRS support in the last release. So we can now talk to DocStore and the Workflow Hub EU. So we can search workflows in their registry. We can import these workflows and run them. Yeah, so in that regard, Galaxy plays nicely with all these initiatives. We have bioschema support and schemas.org support. We try to annotate our tools with all crazy identifiers that are out there so that you can interlink all these identifiers. We are actively participating in a few of the GA4GH work streams, at least the things that make sense to us. So the Pulsar server, from a technical standpoint, is more or less a test endpoint. So I think in GA4GH you would call it a test endpoint. It's just that the Pulsar server and the Pulsar concept is now whatever 8 years old or something like that. So it would be easy, I think, if not trivial, to add a test API on top of that. So in that regard, many ideas are aligning pretty well. And if it makes sense, we can implement these APIs as we did for the TRS stuff, for example. And also for AI, so we support the Elixir AI. This will now be the life science AI. So we are also kind of looking at the GA4GA password thing and so on. And if these specs are ready, yeah, we are probably happy to integrate it. I mean, it's always a question of time and priority, but there was, or I'm not aware of any big problems here.
I hope, Mark, that answers your question. The remaining questions, there are a couple of other questions, but all seems to be around the other disciplines outside life sciences. On one of the first slides, you mentioned the spectrum of disciplines that are benefiting from the setup. And the questions are around what was the penetration of the use of Galaxy into those disciplines, knowing that those other disciplines may have other kind of competitor or dedicated portals. The other set of questions about this area is that how do you segment, for example, the resource allocation across disciplines? How much control you have on that? And how do you customize the tool set for those disciplines?
Okay. So the penetration is probably not big. So the communities outside of, let's say, the bioinformatic domain, so genomics and so on, proteomics, is probably not that big. But to be honest, it's enough if 1 or 2 groups worldwide are getting their open source tools into Galaxy. And this is enough to create a momentum so that people actually see, hey, this is now super easy to run this workflow. So we have seen that in a few communities, that once this initial threshold is passed, so whatever, you have 5 initial tools of your community in this framework, then our experience is that it's a rather fast uptake in those communities. But I cannot justify that. So I don't have hard numbers. I just know that it's usually 1 or 2 very active research groups that spend a lot of time and energy in this entire reproducible stack. So I'm not just talking about Galaxy, but getting their tools into Conda packaging system, getting containers ready and reproducible, automatically created. This I count as more or less the reproducible stack that we have developed. And a lot of people are uptaking that also in the EOSC Live context and so on. We know that there's a huge intersection with EOSC Nordic and EOSC Pillar. And I mean, from my side of, if people are using Conda and containers already and making their workflows in that sense already reproducible, that's always a big win. If they do the last step and integrate their tools into Galaxy, I mean, this is then the cherry on top for me. The other question was about compute resources for these communities.
Yes. Yeah.
So currently we don't prioritize. So the climate community has the same priorities than the genomic community. So I don't want to decide who gets more priority here. And as long as we have the compute power and this Pulsar network is growing, I don't see a reason why we should prioritize certain communities over other communities. And if so, we have these user conferences. This is probably a process that we discuss democratically and not on a admin basis, and when one admin decides who gets how many resources.
Mm-hmm. Right. And one comment or question relates to this was that how does Galaxy overlap with EGI EOS, and is it possible to deploy a Galaxy endpoint through EGI? Which I try to answer. The answer is yes, it's possible. And actually some of the resource providers which were on the slide are included in EGI as well. And so CESNet, for example, CESNet, maybe others too, Raspberry as well. So I think any of the EGI Cloud, at least the EGI Cloud providers, can easily support this through the Pulsar network. And I think a couple of months ago, we even sent out an invitation to the EGI providers to support this setup. And from next year, when we start the EGI ACE project, we will do it more strongly, and we will put more effort into the support of this setup from the EGI resource provisioning side. I'm conscious of the time, so I suggest to, I don't know if we should skip the demo and go to the last part, because I know you prepared a couple of points about future challenges or opportunities.
Yeah, this is just so I mean, we are now in a situation where we have a growing user basis, and that's super cool, but this also has the challenge of we need to scale up our user support. So, which means, I mean, once in a while tool crashes and so on, and we need to answer these things. Also, if you maintain a tool set of 2,500 tools, I mean, I don't even know which tools are currently all installed, right? And I'm not able to read all debug messages from 2,500 tools. So there's a certain lag now. So we really need to invest more now in user support, but that's probably the same as any other service. Once you have users, which is cool, you need to support them. And this is currently one of my concerns, that we also now scale up user support. We try to actually, because we are in this nice situation that our users are also biologists. So we actually try this model of users help users. So we have a built-in chat into this platform so that a user can ask a question and hopefully another user answers them. This is pretty much like a social network just for data analysis, but we need to invest more in that, and we need to scale up user support in all dimensions. Another service that we offer on top of Galaxy is what we call training infrastructure as a service. So just imagine you want to give a training for 50 people and you want to run a specific workflow. You want to ensure that for all 50 people, this workflow will run and not be queued. So what we offer is, you register your training event with us and you say, in this week, 50 people, I want to run this workflow. We estimate how much resources you need. And then you will get for your training a dedicated pool, a dedicated queue, a dedicated HD Condor queue. And all users in your training are automatically redirected in this HD Condor pool. But also that is highly, frequently used and frequently requested. So in a few years, we have now 150 of these training events where we just provide the infrastructure. So this is, I don't know, 2 trainings a week that we run on this infrastructure. That are running on this infrastructure. And this also needs to scale somehow. So we need to manage these requests and so on. So there is now a lot of actually human support and maintenance for the user involved, not on the technical, on a technical level, okay, but this additional step. A question for the EGI community is more or less, we are in the need of a meta scheduler. So if you imagine you have one system that actually can submit jobs, or you have a multi-user system that submits jobs across the globe, the question is really, you need to have kind of a meta scheduler that asks, is Australia actually free? Is Spain free? Or I submit to UK, or I process it locally. And Galaxy don't want to reinvent the wheel, and Galaxy don't want to become a meta scheduler. So the question is there a meta scheduler? And what I have read so far is that nothing very popular and nothing very in production. So this is a big need that we have to make this Pulsar network more efficient, so that we actually can say, okay, this job now goes to Italy because of whatever, they have free resources. So this is one thing that we need to work on in the next years to solve that. A very related problem is local caching of data. So I already mentioned that we use a CERN VM file system quite extensively to mirror what we call reference data sets. So models and genomes that don't change over time. And we mirror them with CERN VMFS to all these Pulsar endpoints. But obviously we could be way smarter with some EGI technologies or an IRODS cluster, so that IRODS is more or less taking care of the file staging, or could be smarter. At least that's something that we want to look at, and I'm pretty sure you guys have experience in that already. And the overall, I guess this slide is mandatory, is the sustainability of the project. Who knows how funding goes in the next years. So what we are trying is that the entire setup, so usegalaxy.eu is completely hosted on GitHub. So everything that you need to deploy a UseGalaxy EU server or clone, it's everything on GitHub. So from the playbooks to Terraform. If we change a configuration, you actually need to create a pull request against a GitHub repo. If that is merged, it gets redeployed. So with that model, we also try to take care in the case that we cannot fund ourselves in the future, that someone else can jump in and spin up a UseGalaxy EU clone and so on. Yeah. But sustainability is always a big problem. But yeah, since we are a framework with a lot of different abstraction layers, we are actually in a position to play nicely with other initiatives. And if you are just interested in one particular part of Galaxy, then just use these libraries. Or if you want to reuse components from the graphical user interface for other projects I've seen today, feel free to use the web components and so on. So I hope that this will kind of help also for the sustainability aspect of this community. Yeah, these are the biggest challenges, I think. So it's not so much on the technical side. So I think we have that kind of under control. But the next step is really to scale also in user support, ensure that this service will survive the next 5 or 10 years. Yeah, and make more users happy. I mean, that's always the aim, isn't it? Yeah, with that, I would like to acknowledge a lot of different infrastructure providers worldwide, actually, because the Galaxy project is a worldwide project. Yeah, the team and the overall Galaxy community that has made that possible. So there are hundreds of researchers that integrate these tools into Galaxy. There is this Galaxy core framework that is developed. So there are hundreds, if not thousands, of people that I need to thank, but especially thanks also to our group here in Freiburg that is responsible for the European Galaxy server. And yeah, since now is the 3rd of November, important day in the USA. That's more or less my last words. So happy to take questions.
Thank you. On the previous slide, what's the grouping? So why do you have two sides of?
Oh no, this is so on the left side is more or less a group here in Freiburg.
Okay.
And the right side is more or less just a picture of a small subset of the community. So there's no.
Because I was wondering, what's the size of the developer team behind this, and what's the size of the user support team behind this?
So the developer is a tricky question because it's an open source project. So you can go to GitHub and see how many people have committed in the last year or something. And it's all spread over the world. So I think in the committers group, so people that have actually merged access to the repo, it's probably around 20. People that help the community is, I mean, in our group, or let's put it that way. There are currently 3 people worldwide completely funded to help users. So that we have a help forum, question gets answered and so on. So they are full-time equivalents that are just paid for user support. But of course, every one of us in our daily business helps users as well. So it's hard to measure, but yeah, it can definitely be more.
Thank you. I'm just checking quickly the chat. I see more kind of opinions, statements than questions. If somebody had a question, can you point out? Maybe just copy paste it again or something. They pointed out that it's important statement, or pointing out that it's difficult to convince the funding agencies to put money behind these activities despite the huge reach.
I mean, I'm quite new in this business of getting money, to be honest. But yeah, I mean, the Galaxy project is more or less a grassroots project. So it's more or less, yeah, it's not a top-down project, let's put it that way. So I think those projects have it a little bit more problematic to get funding. But I think overall the Galaxy project worldwide is doing quite well.
Indeed, yeah. Indeed. The numbers are impressive. So I see no more question. Okay. So I thank Björn for the very interesting talk to close the day. And thank you everyone for attending, and see you all back hopefully tomorrow when we start the 3rd day of the conference. Thank you, bye.
Bye-bye.